In the past few weeks, we've talked about the idea that everything is data, and we've also explored the importance of AI security verification. Today, we're going to connect these threads and see why DeepSafe has chosen security as the very starting point of its ecosystem strategy, and how we will move from a single-point breakthrough toward a comprehensive and long-term layout. In the world of Web3, security issues are everywhere. From the safety of funds in DeFi, to the reliability of data in AI applications, to the protection of identity and privacy, everything ultimately comes down to one core demand: verification. We need to know whether data is genuine, whether a transaction is secure, whether an identity is trustworthy. And because of this, a verification network is not just a nice-to-have feature. It is the foundation, the essential infrastructure that makes the entire system possible. The decision to begin with security comes from three simple truths. First, security is a universal pain point. No matter if it's finance, AI, or social platforms, there is always a need for verification. Second, verification is not optional, it's a hard requirement. Without it, the system cannot function at all. And third, once a verification network reaches scale, it naturally gains network effects, creating exponential value and building a moat that grows deeper over time. Based on this vision, DeepSafe has designed a three-layer strategic framework. At the base is the technical infrastructure, our self-developed CRVA mechanism, together with cryptographic tools like RingVR, FT, and MPC. These ensure that the verification process is secure, randomized, transparent, and scalable. On top of that comes application adaptation. With standardized APIs and SDKs, developers across different industries can easily integrate verification without rebuilding everything from scratch. And finally, there is the ecosystem collaboration layer. Beyond technology itself, we are building a network driven by incentives and partnerships, connecting verification nodes, developers, and applications into a positive and self-sustaining cycle. You can think of it this way. The first layer is the hardcore technology. The second layer is the adoption toolset, and the third layer is the network effect. Together, these three layers form DeepSafe's real strategic moat. Looking back at our narrative, from data is the new oil, to AI requires security verification, and now to ecosystem strategy, the logic has always been consistent. DeepSafe is not here to fix just one isolated problem. We are building a full-spectrum verification network, step by step, to become the most trusted security foundation for both Web3 and the AI era. When we talk about DeepSafe building a full-spectrum verification network, a common question arises: what can it actually do? And how is it different from a traditional security company or an auditing firm? The answer lies in what we call a capability matrix. DeepSafe is not limited to solving one isolated problem. Instead, by creating a unified verification foundation, it can cover the critical needs of many different domains. Take DeFi, for example. Finance is the most direct and sensitive scenario. When asset security fails, the losses are immediate, real, and enormous. That's why in DeFi, DeepSafe focuses on three core abilities: verifying smart contract security by combining automated checks with human audits to ensure code is free of vulnerabilities; securing cross-chain bridges through mechanisms like multi-signature and time locks to minimize the risk of hacks; and validating DEX transactions in real time to assess risk and detect suspicious activity. With DeFi already reaching hundreds of billions of dollars in market size, verification is not optional, it's a fundamental necessity. Now consider AI and machine learning, a much more frontier domain. Many of us are using AI every day, but few stop to ask, can we trust the data these models are trained on? Are their behaviors transparent? Here, DeepSafe provides verification for training datasets to ensure models are not built on dirty or illegally sourced information. It brings accountability to AI agents by making their on-chain decision-making transparent. And it verifies AI-generated content, identifying deepfakes, and tracing their origins. These capabilities not only fill a crucial industry gap, but also place DeepSafe at the forefront of merging blockchain and AI technologies. Identity and data privacy are another essential area. In Web3 social environments, trust is the foundation of all interactions. DeepSafe enables decentralized identity verification to ensure users are real people rather than bots, strengthens social trust by validating network connections, and empowers individuals with data authorization tools so that they truly control how their information is used. This becomes the very cornerstone of social trust. And finally, there is the physical world supply chains and IoT. DeepSafe extends verification to tangible assets by enabling provenance tracking, ensuring every product's journey from production to consumption is traceable. It validates the authenticity of audit sensor data, preventing falsification. And in areas such as carbon footprint tracking, it can record and verify every piece of environmental data with credibility. Across these 4 domains, DeepSafe is not delivering a single, point-to-point solution. It is offering a capability matrix. Wherever trust is required, whether in finance, AI, social platforms, or supply chains, DeepSafe provides the verification network to support it. Put simply, DeepSafe is not just another tool. It is a universal foundation. Much like TCP/IP in the early days of the internet, it doesn't dictate the applications you build on top, but it ensures that every application can run securely and reliably. When we talk about building a verification network, technology alone is not enough. To make it truly work, what's needed is collaboration across the entire ecosystem. And this is the part that determines whether DeepSafe can transform its technical advantage into a long-term moat. The first piece of that strategy is partnerships on the technology side. DeepSafe has chosen a multi-chain approach. Why? Because relying on a single chain is too risky, and each blockchain has its own unique strengths. In the Ethereum ecosystem, we focus on DeFi security verification, leveraging its liquidity advantage. On Solana, we emphasize high-frequency trading verification because its performance is built for that scenario. On Layer 2 solutions, we tackle the challenges of cross-layer verification, helping them scale more securely. And on emerging chains, we provide the most fundamental layer of security verification, capturing the benefits of early ecosystem growth. This multi-chain strategy not only spreads out technical risk, but also gives DeepSafe a built-in network effect across ecosystems. The second piece is building an ecosystem of application partners. DeepSafe will form deep collaborations with leading projects. The criteria are clear: strong TVL, strong technical teams, and highly active communities. The way we work with them isn't one size fits all. It can start with simple verification service integration, and then evolve into deeper technical co-building. This not only makes top projects safer, but also places DeepSafe at the center of the ecosystem. At the same time, we won't ignore the long tail of smaller projects. In fact, we'll actively support them by offering low-cost or even free basic verification services, along with SDKs, documentation, training, and hackathons to help them grow quickly. In this way, DeepSafe captures the influence of top projects, while also building breadth through the long tail. The third piece is about industry alliances and standards. In any emerging industry, whoever defines the standards also defines the rules of the game. Verification is no exception. DeepSafe is working to promote standards on 3 levels. The first is technical standards, such as verification protocols, interface specifications, and security classifications. The second is business standards, such as service-level agreements, pricing models, and dispute resolution mechanisms. The third is governance standards, which include decentralized governance frameworks and incentive design. By taking the lead in setting these standards, DeepSafe can create an ecosystem lock-in effect that encourages more projects to join, while also making it easier for regulators to recognize and accept the network. So to sum it up, DeepSafe's ecosystem collaboration strategy follows a 3-step path. First, using multi-chain cooperation to unlock technical scenarios. Second, driving application growth with a dual engine of top projects and long-tail projects. And third, establishing long-term barriers through standards and governance. Put together, these 3 steps form DeepSafe's true moat. It's not only about technological leadership, it's about turning the verification network into the trusted infrastructure of the industry through partnerships, collaboration, and standard setting. When we talk about ecosystem strategy and collaboration, there's a question we can't avoid. How does DeepSafe actually capture value within this system? In other words, how do we turn the value of verification services into a sustainable business model? The first layer is a diversified revenue model. Since DeepSafe positions itself as the infrastructure of the verification network, it doesn't rely on a single stream of revenue. Instead, it participates in value distribution across the ecosystem in multiple ways. In the DeFi space, for example, we can work with applications on a revenue-sharing basis. If our security verification helps them avoid massive losses, then naturally, they're willing to pay. For validation nodes, we use economic incentives to ensure their participation and share in the rewards. For developers, we can design incentives based on SDK and API usage. This way, DeepSafe's revenue isn't tied to one point of dependence, but instead permeates the ecosystem from multiple angles. The second layer is the token economy. In the blockchain world, tokens are more than just a means of payment. They are like the operating system of the entire network. DeepSafe's token design revolves around four core functions. First, verification rights. Users who hold a certain amount of tokens can become validation nodes, gaining both operating rights and a share of rewards. Second, service payments. All verification services are settled in tokens, which not only simplifies payments, but also ensures token circulation. Third, governance participation. Token holders can vote on protocol upgrades, parameter adjustments, and even the future direction of the ecosystem. And fourth, staking. Nodes and users can stake tokens to earn yields, while simultaneously enhancing the security of the network. This design ensures that tokens have real utility, while tying their value directly to the growth of the entire network. But revenue and tokens alone are not enough to build lasting advantage. What DeepSafe truly focuses on is the network effect of value capture. As more projects connect to the network, verification data accumulates, and that data itself becomes valuable, helping us improve accuracy and efficiency. At the same time, the more projects depend on DeepSafe, the higher the cost of leaving, which further strengthens the moat of our ecosystem. In other words, DeepSafe's business model isn't about simply selling services. It's about embedding the verification network directly into the flow of value across Web3. Like electricity or water, it becomes indispensable infrastructure. To summarize, DeepSafe's business model is built on three layers. The first is a diversified revenue model, ensuring short-term cash flow and market adoption. The second is a token economy that binds the interests of users, nodes, and the ecosystem together. And the third is data and network effects, creating long-term value accumulation and an enduring moat. Combined, these three layers ensure that DeepSafe not only achieves commercialization in the early stages, but also grows into the standard for security verification in the Web3 world over the long run.